right, guys, welcome. So I think the previous panel kind of lined this up pretty well. So we're going to chat a little bit about the practical challenges when implementing BitVM and how you guys are all addressing them in your own special, unique ways. I think before we dive into the deep end, it would be great for each of you to introduce yourselves and maybe introduce the project that you're working on that's using a BitVM bridge. After you. We'll go this way down the line.
Sweet. I'm Greg. I know what you're thinking. Damn, he's a lot of plastic surgery in the last few minutes. I'm clearly not Alexi. So I'm lead engineer for Bob. I'm here to discuss more the engineering side of BitVM. Bob is a layer 2 rollup on Ethereum. We're looking now to integrate the BitVM bridge, so we have a native bridge from Bitcoin. So our narrative's sort of a hybrid rollup where we settle to do two different ecosystems and combine the best of both worlds.
So hello everyone, I'm Hanzhi. I'm one of the co-founders of Nubit, and I'm also a PhD student at UCSB, where I do research in blockchain and security. So at Nubit, we're building a world computer for Bitcoin, which will enable more native use cases. And as for BitVM, we have built a formal verification tool for Bitcoin script to formally verify the Bitcoin implementations. And yeah, that's it.
Cool. And I'm Aaron Feickert. I am the research engineering lead for Alpen Labs. And Alpen Labs is working on Strata, kind of a stack of technologies, including a BitVM bridge implementation, kind of a modular orchestration layer upon which we're building Strata, which is an EVM-compatible rollup. But the modular nature of the stack is intended to kind of allow multiple execution layers in addition to this. So hopefully building like a nice kind of cool ecosystem on top of Bitcoin in this way.
Okay, awesome. Okay, so just in honor of the title of this panel, I'll actually kind of turn my first question over to you each to share what you think are maybe some of the biggest practical implementation challenges that that your projects have individually faced and how you've sort of uniquely handled them.
I think from our side, so there's a few different components to BitVM, of course. There's all the more infrastructure side. There's the upstream, all the stuff you see in a BitVM core. This is the stuff that you are looking into, compiling that Groth16 proof into Bitcoin script and all the assert transactions, all that. There's a lot of complexity there, so there's a lot of engineering challenges there. And related to that, there's things like size and complexity and making sure these things are executable on Bitcoin. So this is something we faced where we're trying to reduce the size of the assert transaction, for example, and make it more practical to use BitVM. Then there's the other side, which is the prover, at least for us. So I think projects do it differently. This is the zkVM application that's proving the finality of Bob, at least. So for us, there's engineering challenges there and how we work together with. So to lay the ground, we're working with Babylon now. Bitcoin stakers will secure the Bob chain on Ethereum, and we will prove that finality in a zkVM application through BitVM and also Ethereum. So related to that, there's many engineering challenges where we're working with Babylon to make it simple to verify Babylon, ensure that there's sufficient economic security so it's difficult to attack. This is also related to some upstream challenges in BitVM core. And yeah, so we're hoping little by little, we're going to roll out our testnet and our mainnet, add some training wheels, some trust assumptions, and gradually scale it down to a more permissionless system.
Yeah, for us, I think the major challenge in implementing BitVM is because it's way too complex. Yeah. It's basically it's too complex, and maybe there are only 30 or 40 people in this world can truly understand how it works, and if only these people can understand how it works, we cannot say it's really trustless because you need to trust these experts. So to mitigate this problem, we have built a formal verifier, which are essentially use computer programs to verify the correctness of the underlying Bitcoin scripts. And this way, we can finally remove the trust of these experts. We can just trust mathematical proofs to tell you whether this implementation is good or not. Yeah.
Yeah, I mean, if you're at the last panel, Robin, who kind of came up with the idea, indicated that there's a whole lot going on with BitVM. And definitely, like, the issues that have been brought up are issues, I think, across the ecosystem. I think one of the things that our team has particularly noticed kind of throughout the time that we've been working on building and building on BitVM is the fact that if you go through and kind of read through the design in the original preprint, you'll kind of see it's presented in sort of an isolated way, where it's presented in the context of kind of one deposit into a bridge and withdrawal coming out. But in practice, we have a lot more that's going on. Robin did mention, for example, kind of a light client design where we need to be able to sort of do introspection on the Bitcoin blockchain, which can't really be done natively. So in some sense, we have to kind of emulate this. Robin indicated that there are several designs at play. Our friends at Citree have come up with one. We at Alpen came up with one. Robin and others came up with one and then proceeded to break it an hour before coming here. This is the nature of research. You build things, you tear them down yourself, or someone else tears them down for you sometimes. So kind of finalizing and working out what the trade-offs are in those designs, I think is complicated both from almost kind of a practical standpoint where you need, you know, operators and ecosystem participants to kind of play the game with you here and use your system, but also just from kind of an engineering standpoint, because each of these different approaches to something like light client management impose different trade-offs and impose different levels of complexity at different layers in the stack. And you know, there's several other things that we've been kind of working on, but one, I think, additional particular challenge that we had was kind of looking at capital efficiency and operator liquidity. So if you kind of, again, look at kind of the way that BitVM in the preprint presented things, it was presented in the context of, oh, you know, an operator puts in some liquidity in, at deposit time, and we just kind of take things from there. But of course, ideally, in practice, if we do things correctly, many people will want to deposit into the system and, you know, later kind of effect withdrawals. And how are we able to handle that in a way that allows operators to be able to, you know, manage their liquidity properly and not have to scale this in an absolutely unfathomable way? And I can't speak to necessarily what other folks might be doing, but we've come up with some designs for this that we think are going to be, I think, pretty practical. You know, of course, they add complexity, as was mentioned. BitVM is complex, and the way that we solve these problems kind of inherently adds additional complexity. But we think it's manageable in a way that we can handle.
Yeah, I'd actually love to hear from you two. This was going to be sort of my next question.
Did I usurp your
told you in
question by my answer? Well, I was already thinking of it anyway, so I don't think that counts.
No, but I think something that I'm curious to hear from each of you is really just sort of how you're all thinking about liquidity management for BitVM bridges and for operators of these bridges, both on the side of just, okay, you know, BitVM is an optimistic system, and so, you know, it's expensive when there is a challenge and you're doing these sort of, you know, extravagant commitment games. How do you manage liquidity on that side? How are you thinking about liquidity management on that side? And then also, I think more broadly, and this is maybe a bigger question we could even do separately, but thinking about, you know, just managing the peg, you know, assuming that these things are really successful and you have, you know, lots of wrapped Bitcoin or whatever the assets are on your execution layer, whatever that may be. You know, how do you have operators kind of match that, right, and kind of execute like an effective peg? So yeah, liquidity management in general, I think, is like a really big topic. We'd love to hear both of your thoughts on that, and maybe even get a little bit more color from you on the second category.
Yeah, I mean, related to that, I guess there's also a bit of an issue with the lifetime of what we call BitVM instances, right? You open them and close them whenever you want to peg out. But if they're kept open for a sufficiently long amount of time, the liveness of the system kind of degrades. Operators may be online, maybe offline. So that's an issue kind of we're thinking about as well. Long term, how we do that in terms of maybe rotation, that sort of thing. But to address your question more directly, I guess, so trying to tread carefully here what we've announced and not announced, we are looking at like a sort of a BitVM joint partnership program where we can onboard custodians and institutions and these kind of players. Who will be the big players managing the BitVM pegging? So these are the ones that are chunking in 10 Bitcoin at a time, 100 Bitcoin, and managing that, at least on the Bob system, more likely across the BitVM space. From there, we're looking into other ways on the DeFi level we can integrate that so end users don't bear the cost of complexity, so they don't have to think about BitVM at all when they just want that trustless asset. And then we look into the UX and wallet support and having simple ways for like atomic swaps. I think Robin I was in a talk he was doing earlier, and he said, I think he agreed with me, this is one of the best solutions we can have for the onboarding of liquidity on these chains is to just have atomic swaps for end users and then move that directly into DeFi.
Yeah, for me, I think we do need some like kind of like right incentives for the like operators to provide liquidity. But I think the major like way to do that is to really like, educate these operators to make them trust the system, so they can like willing to provide liquidity and take this as like arbitrage opportunity so that they will like provide as many as they can. So basically, the peg will the peg can be matched, and that's the way. Like I think it's more natural to the market.
Yeah, I'll only say like a little teeny bit more, since I did speak to this a little bit more.
Bring it on.
Yeah, but so I mean, when it comes to just ensuring that operator liquidity scales well, in the sense of if an operator wants to be handling multiple BitVM instances at the same time, obviously we don't want them to have to scale the amount of capital they're putting in. We've kind of come up with like this kind of stake chain idea that adds yet more transactions into the BitVM instance, but we think in a very nice controlled way that solves this in I think a pretty elegant way. Coming up with kind of a well understood model for how to handle the economics of operator liquidity. If you obviously are setting this kind of crazy high, then of course you're limiting the types of institutional operators or other players who are going to want to come in and act as operators. But at the same time, the fact that, as was mentioned, these games are often long running, and it's difficult to kind of predict what the chain is going to be doing and what the fee market is going to be doing. So it's a very careful game that we call BitVM games. It's also a very careful game that you have to play in order to kind of see where you think fee markets are going to go and how to balance the amount of stake that operators have to put in with some of the other elements of the BitVM game that come into play. Things like what are the costs of the transactions that have to go on chain. As I don't remember, it might have been Robin who mentioned this. You want to make sure that the losers always have to pay in this case. So if you're going to be a malicious player in this game, then we need to make sure that like the incentives are lined up to make this work. It's something that like is still very much like an active area of research. Unless someone else has solved it, in which case I'd love to know more. But it's something that we're all, I think, looking into very carefully to make sure that we can build this system, for the long term.
Awesome, and I promise this is going to be probably the nerdiest question that I ask all night, and then we'll go into a little bit more kind of like broad overview questions. But so one of the ways, right, that we can sort of reduce the capital costs associated with these BitVM games is just thinking about compression, how data is packaged, how we can basically get these commitments as small as possible. And I know that different teams are sort of thinking about that in different ways and sort of have different ways that they're thinking about data optimization. Do you have any particular notes that you want to share about that?
I mean, I think I addressed this previously. So yeah, there are obviously code level optimizations we can use to make it cheaper to onboard, to peg in and peg out. I guess our solution for end users is this sort of atomic swap solution. Like it's a standard now across many systems. We have our own solution that does that called Bob Gateway, and where users can use sort of intents, like we followed loosely across, and some of these other intent solutions in a similar way, so they can onboard Bitcoin to and off ramp from Bob. And I think that's going to be, the best solution for now.
Yeah, I think the ultimate solution to that is basically build a proper compiler for BitVM. So basically, currently we are doing it manually. We are manually implement snark verifier. What if we want to change the verifier, change it to another curve? Do we have to redo all this again? Definitely not, right? So basically, we need a proper compiler so that we can reuse the good optimizations from the compiler people. They have been researching this for years. We can definitely use that. And this way we can further scale the whole development and make BitVM more practical.
Yeah, I mean, there's a lot of things that we can do. We're proud to be part of the BitVM Alliance, so there's a lot of folks who've been working on kind of the underlying plumbing of the BitVM library. How we end up taking this Groth16 verifier and in a very unholy way break it apart and make it work in Bitcoin script, which, I mean, I don't know. At some level, that shouldn't be possible. It's crazy that we got this to work, and thanks to some amazing engineering. I don't know. I'm the kind of person who doesn't like to toot my own horn, so I'll toot the rest of my team's horn and say that I'm very proud of the fact that some of the engineers, especially at Alpen, but certainly not only at Alpen, have been able to take what used to be multiple gigabytes of overall script and bring it down to, I think the latest number is 780 megabytes. Thanks to a lot of very, very low level optimizations in particular relating to how we represent particular field elements that are required to do this kind of verification. As was mentioned, a lot of it is done very manually and in a way that's also very specific to Groth16 verification, and might not necessarily translate over in a very clean way if we were to do some other kind of proving system. Maybe it would. We have many things that we're still working on. Yeah, we could talk more about specific kinds of math related to Groth16 verification, but suffice it to say, like we're able to play a lot with how we do things like numerical representations.
So another thing that I appreciated that Robin brought up in the last panel was that Robin was very forthright about the fact that BitVM is not the end game, right? And that's not the sort of vision that he has for Bitcoin long term. It seems like he was pretty interested in some sort of scripting update, some sort of soft fork to Bitcoin that would propose a more elegant solution for bridging. And I was wondering if each of you might share your favorite covenant proposal and why, or your favorite opcode. Sorry, I'm making myself laugh. Your favorite opcode.
This is going to go great, by the way.
Yeah, this is going to go great. What do you want to see replace BitVM?
I want to be careful not to be too controversial.
Just say it. Just go.
Well,
Yeah.
I will say I was, there's the wiki I was checking a few weeks ago, Robin pointed us towards, I forget where it is, there's a table where we're comparing different opcodes. And I was very surprised, so opcat was top of the list. Everyone was against, like a lot of these figureheads. Robin had put, no, I think he'd put no, I could be mistaken. And a lot of them were quite like, I guess, I don't know what it is, because obviously opcat is one of the most simple one of the most simple, I think, opcodes that we could include that could enable greater scalability on Bitcoin. But I don't know if it's like a political thing now. I guess it's sort of people have kind of made their beds, like it's not going to happen. Like I've made peace with it.
You've made peace with it.
Well, I don't know. I would love to see it, but I doubt it would ever happen at this point. But I don't know. So my answer is anything and everything, hopefully.
All of them. Just get a covenant. Okay. Yeah, fair. Fair question. Fair answer. Go for it.
Yeah, for me, like for covenants, maybe opcat, maybe OPCTV. There are many covenant solutions.
Do you have a preference between them or no?
No, like
No, you're just like get a covenant.
Yeah, and maybe like to optimize the BitVM itself, maybe OP multiply to just like cut down the secret size. And to ultimately replace BitVM, maybe it's a bit too aggressive. Maybe we could have some kind of OPCK verify on Bitcoin. That would be great, right? So yes, that's my take.
Yeah, no one has any favorites. That's okay. I will say
No
that
one wants to say their favorite, but that's okay.
no, and I think that it's weird because I think there's downsides to picking something that is too specific to particular use cases, because if you lose generality, then you lose more use cases. And it's one of those things like if you feel like you only have one shot at it, you try to hit as many use cases as possible. Having something that will enable covenants, of course, would allow for not requiring the emulation that requires this particular pre-signing process that BitVM uses now. I will say, like, I'm particularly interested in opcat for not even necessarily like covenant reasons, but also just like other like interesting plumbing reasons. So there's a lot of efficiency things that we cannot do right now because of the inability to just take two things and just put them side by side. And if we could do that, oh, good heavens, we could move the universe. So there's things we're doing right now with the way that we do in BitVM. The chunking approach that we use right now requires us to kind of pass state around. And we do this with these like gigantic hash-based signatures, and we could optimize those if we could do certain concatenation operations. And there's been kind of this hypothesis that if we're able to do that, maybe instead of needing to do Groth16 verification, that's like wrapping Stark verification and other things like that, maybe we could use something like particular hash-based proving systems more directly, which could allow for a lot of other simplifications. So like even ignoring the whole covenant thing, which we should not ignore the whole covenant thing, but even if you were to, being able to do something like very general like opcat, I think could open up like a lot of like very specific and yet numerous optimizations that I think would be useful for what we're doing here, but I think just like for ideas that we haven't thought of yet, or that at least I haven't thought of yet.
Thank you. All right, so Now we'll get into a little bit more of a fluffy question, that's sort of open to interpretation. I'm curious, and this was actually a suggestion by the Bob team to ask, what do you think is what do you think is the biggest misconception about BitVM? What do you think is, something that maybe folks are kind of getting wrong from the way it's discussed in like marketing narratives that you'd like to correct?
Who asked this question?
This was on my official Bob list of questions to ask. So, FYI.
That's a deep one. I guess like the marketing of BitVM is like optimistic fraud proofs, which alludes to a certain type of construction, right? You compare it to optimism, arbitrum, etc. And you get some preconceptions about how it would work. Obviously, it's a lot different under the hood. There's issues also with statelessness. This is the biggest issue we face in BitVM. I think there's some good solutions now being worked on with regard to checkpointing. Previously, it was this sort of superblock logic. Yeah, I think it's just very different from sort of the Ethereum side, and it needs to be better understood on a deeper level.
Well, I think that people believe BitVM is kind of like a trustless solution, but actually it's not. At least for now, it's like a trust minimized way, since you also need a covenant, and covenant is not trustless. So on Bitcoin today, so I think that's the biggest challenge, that's biggest misrepresentation.
I agree with both of those, but I have like a separate soapbox that I've had for years, which is the fact that anytime someone says, this uses zero-knowledge proofs, half the time the letters Z and K have absolutely nothing to do with the application. And really what they're saying is we would like succinct, verifiable computation through these specific kinds of proving systems. And unfortunately, I think that there is kind of this idea where the letters Z and K imply some kind of like vague privacy related to whatever you're doing, which can certainly be the case, but...
Or just it's a buzzword, maybe. Maybe they don't even know about the privacy. Maybe they just think
well,
it's cool.
But I think the point here is that we don't actually care for what we're doing, for what we're using Groth16 for. Like, we do not care about the Z and the K. Like, we care that it's like a very like nicely structured, succinct proving system. And I guess I would not want folks to be under the impression that because the proving system we're using happens to be zero knowledge, that the protocol that we are integrating it into implies more about privacy or security or safety than folks are actually getting. We can certainly like build those things like on systems that use this, but it's not like some inherent like fact of the universe that you get it for free.
Yeah,
I'm gonna get off my soapbox now.
Yeah, I can add some of my points. So I think it's mainly because the most efficient snarks are all ZK snarks. And that's why
it's a fantastic property. It's great. I just don't want people to I don't want people to misunderstand what they're getting, I think is all. So.
There you go.
But like succinct proving system is like not a good marketing term. ZK sounds cool. I think it's great.
So my personal opinion, I'm so impressed with sort of the BitVM alliance that's been built. I think that it's amazing how these companies are all working together to like make this technology happen. Another one of my questions from my official Bob list of questions to ask, and I'll make this my final question, is do you think that there's anything that any stakeholders in the Bitcoin ecosystem could do, whether that be investors, whether that be developers, researchers, et cetera, could do differently to, push the space forward? And yeah, it's a big question, I know. It was on my official Bob list, I promise. Yeah, we can go back. Do you want to go?
I think from a builder's perspective, basically we need to educate the market more. Like, people don't know what's the difference between BitVM bridge and multisig bridge. They think they are the same thing, which is definitely not. I think that's what we can do now. We can educate the market, voice out, teach people what is BitVM and what it can enable, what it can unlock, and yeah.
I mean, I think I have two big things. I think one of which is, to really help support kind of standardization, formalization, auditing of some of the things that we're building, because they're very cool, but they're very complex. And where you have complexity, there lie the dragons. So I think that being able to support that, whether it's through talent from auditors, whether it's funding, audits are very expensive for a very good reason, because again, there's a lot of complexity there. I think that kind of support would be very helpful. And I think personally what I would also like to see is, again, like I said, a lot of what we're doing, taking these incredibly complex things and baking them down into Bitcoin script. I used the term unholy before. I truly think this. Like, it's wild, like the cool things we're able to do. And they're being done in kind of a very bespoke way right now that I think could be useful to the broader ecosystem in other ways too. And I think I'd like to see, maybe folks who are interested to kind of take some of these cool, like cryptographic, almost like, I don't want to call them cryptographic primitives, like script primitives, and kind of like build some like cool tooling out of it and like see what else you could do with it. Because I think that could also help, I think selfishly that could help what we're doing become like even more efficient and more interesting, and also help what we're doing help other folks. Like that's part of the point of doing free and open source software, is that folks from different areas of different ecosystems can work together and like build stuff that benefits everybody. It's the rising tide lifting boats or something. We're the tide or we're the boats, I don't know. We're something in the analogy. Yeah, something about boats and oceans and tides.
I think, yeah, it's given me some good food for thought. Yeah, I mean, there's two sides to this, right? There's the education, like BitVM is such an unknown technology, like we're really on the front of this kind of war against Bitcoin to bring programmability to it. And so much of the tech is so new and so like unoptimized. We're working together, so many issues, making it more streamlined and scalable. So that's a big thing in education, things like formal verification. This is going to be like critical to the next steps in the BitVM like life cycle. But then there is the side of the users, and this is kind of brings back to like, I think a focal point I kind of been focusing on through some of my other answers is BitVM is awesome, but it should also be somewhat transparent to a lot of end users. People who hold Bitcoin, they don't necessarily care that they're bridging through BitVM. They care about the security, they care about the trust assumptions, but they don't care like about the technology necessarily. Like if you hold CBBC on Coinbase, are you really caring that it's backed by Coinbase? Maybe, but if you're using BitVM under the hood, you just want to know that your Bitcoin is secured and you can use it in interesting ways, in DeFi and a lot of these systems.
That was awesome. Thank you guys.
Cool.
Thank you guys
Thanks
for
for
nerding
hosting.
out with me.
Yeah, appreciate it.